Hi viewers, in this session we will see about the properties of the fluid mechanics. Uh, so the topics I am going to cover: what is the fluid properties, so what is the need, and we will see different fluid properties and the types of fluids and the applications of fluid properties in the civil engineering field. So first you should know that what is the meaning of fluid property. So it is a physical characteristics of a fluid which describes how it behaves at rest and or in the motion. So here this property is very important for the engineers. It may be a civil engineer or a mechanical engineer. If you are designing any fluid machineries, this property is very important to analyze, and also the designing the fluid machineries and also the fluid flow system. The understanding of fluid property is very important. And here if you are taking this need for studying fluid mechanics, as an engineer you should know that here if I am taking the we are using water, gas in day-to-day life. Okay, so here we should know that how it behaves under different conditions. It may be the temperature, it may be high pressure, how it is behaves, and also to design the safe pipelines, channels, drainages. Everywhere we are using. So here we have to predict the flow resistance. Then only we can design the safe hydraulic systems, and also to calculate the pressure on the structures. For an example, if you are designing the retaining wall or dams, so everywhere the water will create the pressure on that structure. So here where that the understanding of pressure and some other fluid properties are important, and also to analyze the ground water flow and also the seepage in the soil. So if you are going for any underground structures where that there may be the seepages of water may be there, and also there may be the groundwater flow. So here we have to study that. And also in some hydraulic structures there may be the water hammer or some cavitation problems may be there. To prevent this, we should know about that fluid property. And also for designing the hydraulic pumps and turbines we are using. And also at finally to get safe and durable hydraulic structure, we should know about the fluid properties. And we will see some of the property one by one. So the first one is the density. So what is the density? So you can see this, I have taken as a gas, liquid and solid. So here you can see that the molecules are placed, the distance between the molecules are more. So which is having the less density. So which means this is a ratio of mass by volume. Here the mass is more in solid. Okay, and if it is less in gas, so therefore the density of solid will be automatically more. And the unit, the SI unit is the it may be kg per meter cube. So if I am taking the standard liquid, that is a water, the water density of water will be 1 gram per centimeter cube. Okay, and the specific weight or weight density is nothing but weight of fluid by volume. So here if I am taking the solid, the weight will be more. Okay, and if it is a gas, it will be less. So therefore the weight density will be less for the gas and it will be more for the solid. And the specific volume. So what is a specific volume? So it is the volume of fluid which occupied by the unit mass. So it is nothing but volume of fluid divided by mass of the fluid. So mainly we are using this property in the gases. And the next one is a specific gravity. So the specific gravity is very important. While we were designing the water retaining structure, this property is very important. Okay. So here for liquid, we are using weight density of liquid divided by weight density of water. So this therefore here the water is the standard liquid where we are taking to find the specific gravity of the given liquid. And if I am going for the gases, it will be the ratio between the weight density of gas to the air. And the next one is the viscosity. So here if I am taking the viscosity, so here you can see this, the water is flowing from the pipe. It is it is flowing very easily. So since it is having the less density and also the viscosity, And if I am taking the olive oil, it will be coming slowly, and the honey will be coming very slowly. So what is the reason? So that will be when the fluid is flowing from one place to the other place, there will be the resistance will be created. So here this resistance will be more in honey when compared to the water. Okay, so it is because of the density. If I am taking that, it is graphically it is represented that the viscosity versus the temperature. So if I am taking, if I am increasing the temperature, if I am boiling the water, what will happen? The viscosity will be reduced. So for an example, if I am heating the oil for cooking anything, so you can see that it is flowing, the oil will be flow very easily, which means the viscosity is reduced. If same thing, if I am boiling the gas or if I am heating the gas, the viscosity will be increased. And the fluid, again the viscosity may be a kinematic viscosity or it may be a dynamic viscosity. And the next one is the fluid Newton's law of viscosity. So Newton's law of viscosity is nothing but it is the states that shear stress on the fluid layer which is directly proportional to the shear strain. So the stress is directly proportional to the shear strain. So it is nothing but the Newton's law. So according to this, we are classifying fluid, ideal fluid, real fluid, Newtonian fluid and non-Newtonian fluid. So you can see this. So this is a graphical representation of the types of fluids. So now where we are using. So viscosity is used to design the pipelines and channels, and density is to calculate the water pressure on dams and tanks and also the walls. The surface tension, capillarity, vapor pressure. So if you are taking the every fluid property is having its own applications. So it may be in civil engineering and also it may be the other engineering also. So now we will do this. We will see some the summary of this thing. So we have studied the basic characteristics of the fluid under pressure and what are the different properties and what is the Newton's law of viscosity, and according to that how the fluids are classified and how it is used in the field of engineering. So thank you for listening this video. Thank you.